All right, guys, welcome to the webinar, Uncovering Warning Signs of Your Fungal Disease in Your Growing Environment. So I'm going to launch a poll. If you can let us know where you're dialing in from today. Awesome. So it looks like a majority of you from the United States. Welcome, guys, and everybody else here on the call. My name is Kayla, and I'm joined here today with Daniel.
Hi, guys.
So a little bit of housekeeping while we wait for some of the latecomers. First, please go ahead, put your phone on silent, turn off any notifications or anything that might distract you during the presentation. And this is including the 50 browser tabs that you have open right now that I just closed myself. We have some really great information here today, and we do need your full attention. Secondly, if you have any questions, please go ahead and post them in the Q&A box at the bottom bar. There's going to be a Q&A button down at the bottom. We're going to try our best to answer them during the Q&A session towards the end of the presentation. Then for other comments, please feel free to use the chat function, and then we will be launching a couple of polls like we just did throughout the presentation. Lastly, the webinar is being recorded. So shortly after we finish, you will receive an email with the link to the replay. And this will be useful if you need a boss or somebody else to watch it. And so please note that the replay will be available until Monday at 9 p.m. Eastern time, and then it will be taken down. So that is all that I have for housekeeping. And so today you're in the right place if you feel like you could be doing more to understand some of the deeper aspects of your climate and crops, but don't really know where to start. Maybe you've had some pests and disease and want to minimize that impact in the future, or you're interested in moving away from growing manually so that you can free up more of your time to focus on developing and growing other parts of your business. But first, we do want to properly introduce ourselves. My name is Kayla, and I am a Folium Business Development Manager here at Autogrow. I am from a farming family, and I knew I always wanted to be an ag. And once in college, I did become passionate about CEA and hydroponics. Then I did have a stint as a grower at Bright Farms before joining the team here at Autogrow. And so now I help growers optimize their climate and irrigation systems so they can grow absolutely beautiful crops. And I'm joined today by Daniel Fan, our field trial specialist. Dan, can you go ahead and tell them a little bit about yourself?
Yes. Hi, everybody. Like Kayla mentioned, my name is Daniel, and I manage the trials here at Autogrow. So my background is in science, more specifically in biotechnology. I spent a lot of time with microbes and plants, but more recently, I managed a farm operation, and I got to experience a lot of the things that the growers online today experience on a daily basis. And from this experience, I realized the importance of having technology inside in this industry, and that's why now I'm part of a great team here at Autogrow.
Well, that is a bit about us. Who do we have on the call today? Can you tell us about your current role? We got a lot of different types of people, but it does look like top of the list at the moment is growers. So, but great to have all of you guys here on the webinar with us. So first, here are some of the things we're going to cover today. First, we'll talk a little bit about the typical greenhouse scenario, how growers interact with their crops in the environment, their methods, and the tech that's being used. Then we'll drill down a little bit more into the limitations of these scenarios. After that, we're going to highlight some of the climate warning signs that can trigger different aspects of fungal disease outbreaks.
After that, we're going to talk about a case study that we did with one of our growers. And I'll go into very specifics on the disease itself, how that happened, and we'll even go into the financials and impact to the business. After that, we'll talk about the ideal greenhouse monitoring scenario. So what do growers need to monitor, and what kind of sensors do you need?
Lastly, we are going to have a Q&A to answer any questions that you might have. And be sure to stay to the end to get access to the case study about basil and botrytis. Stay to the end and you will grab that for free, and we'll post a link for that in the chat. But now let's dive in. First, I want to talk about the current status of things, or what I would call a typical greenhouse scenario. Usually in a greenhouse, you have shade screens, HAF fans, extraction fans, lights, things like that. All of that is usually controlled with a controller or by timers and thermostats. But even with all of that hardware, the typical greenhouse scenario really only has one environmental sensor in it, maybe two if you're lucky. And these are usually placed at the center of the greenhouse or the center of an indoor space in an attempt to get a reasonable average across the entire crop. But if you think about it, the single point is usually only 2 to 3 feet above the top of the crop. And that's not even close to providing a comprehensive picture of what's actually going on in the environment. So growers tend to compensate for this by taking manual readings with handheld equipment and doing multiple crop inspections over the course of an entire day. But what this approach means is that growers are continuously reacting to what's already happened and are not able to identify the threats to their crops before it's too late. So I can speak to this a little bit, because of my experience. When I worked as a grower, we would do walkthroughs to the greenhouse to look at crops that were going to be harvested that day or within the coming days. And sometimes everything was fine, but sometimes certain crops would take a hit. And we had to do a lot of extra work to understand really why that was happening. We did use lots of handheld sensors in order to check things, but if I did have to sum up our approach with one word, it definitely would be reactive. So this is the first common greenhouse scenario. The other one that we come across is where growers are not using any sensors or controls at all. And so in this instance, everything is manual. This means you're taking readings, moving fans around, opening and closing vents, absolutely everything. And as you can imagine, this is very labor intensive and keeps growers busy at all hours of the day, the night, weekends, and unfortunately your holidays as well. So one thing we would like to know, do these scenarios sound familiar? I think both of them are pretty common and that my experience is pretty typical, but what about yours? Tell us about how you're currently monitoring your growing environment. It's awesome watching you guys come in and vote. Lots of moving parts, but we got a couple that definitely stand out among the others. Well, looks like the top winner is most of you guys do temperature, but then really close behind it is that light and relative humidity. So it's really fascinating and it'll be really applicable as we go into the case study later.
So I'm going to talk to some of the limitations of the scenarios that Kayla mentioned earlier. These are just some of them. So if you don't have a sensor, you're going to be doing things reactively like Kayla mentioned. So that's the lack of a proactive approach, and you're going to be putting out fires as they come up rather than being a step ahead of the game, so to speak. It's also very labor intensive, especially if you're taking handheld readings. I used to take handheld readings and, it's subject to human error when you write down your records, or if your staff does. But I think more importantly, if you're taking handheld readings, is you're taking a snapshot in time. So if you think about a greenhouse, you go in there and the sun's out and the temperature is nice and warm and you get your reading and you go back. The next minute, the cloud comes over, especially if you're in a part of country like I am, where it's rain and shine on and off all day. So you're not getting the full context of the day. The other problem and other limitation of having no sensors is you're relying solely on visual evidence. And this can be too late to minimize the impact of your disease. Of course, you need to do your scouting and you do need visual evidence, but if this is solely what you're using, then it's not the best. The other thing is having blind spots in your climate monitoring. If you're using one sensor across a large greenhouse, it's very obvious there are hot spots, there are humidity pockets, there are microclimate enclaves, and there are many different reasons why your greenhouse will have different microclimates. And if you're taking one reading in the middle, you might not be picking up the disease that's happening in the corner. All of this has an impact on your opportunity to supply and your pockets. In the end of the day, growers, we're in business and we want to be able to produce as much as we can without that loss. And the final thing I have here is that relationship with your customer. So this is speaking to if you pre-sell to the supermarket, for example, or you have promised a wholesaler a certain volume and you cannot meet that demand. If you have these disease scenarios, then that relationship can be damaged.
So really, all of these things come down to this. Neither of these common growing scenarios actually help you identify your microclimates, and that means you're in the dark about the things that can significantly impact your crop yield. When I was a grower, we could definitely feel the variation of the climate as we walked through the entire greenhouse, and I definitely didn't know it at the time, but what I was feeling were those microclimates. And the crazy thing is that while we knew they were there, we didn't know the actual impact that they were having on our crops. Example I could provide is that, if we saw a drop in harvest weights, we could look back at the data that the controller sensors were reading, but we truly didn't know what was happening at the crop level.
Cool, so let's talk about some of the climate warning signs. Now, this is a list of 4 things, by no means the most exhaustive list, but I think these are some of the very, very common ones. And it's very comforting to know that most of you selected humidity and temperature, the sensors that you use. So that's really good. And I'm going to speak to these. The other thing I want to say is that there are a myriad of diseases out there, pathogens, plant pathogens. And I'm specifically talking about the airborne diseases. So that's the diseases that affect your foliage, your fruit and so forth. Not so much your soil-borne disease, because that, like Pythium, Phytophthora, Fusarium, those kind of diseases, that's probably more your soil moisture or your oxygen level in your tanks and stuff like that. Or if you're using clay, that has not much oxygen in there as well. So this is more your climate warning signs. So the first thing, high humidity. Diseases like botrytis, rust, algae mildew, downy mildew, Erwinia, Pseudomonas syringae, I mean, the list goes on. They absolutely love high humidity. And so if you're growing your crops very densely together, that lack of airflow inside your crop and the added transpiration will create that really high humidity. And if you're taking measurements or readings high above your crop, you're not going to understand the warning signs the plant is showing with that high humidity. The second thing I've listed here is temperature. So you've noticed that I haven't said high or low, and that's because pathogens have their ideals. So botrytis, for example, they prefer the lower end. Rust, algae mildew, perhaps more the mild, and maybe algae mildew, slightly higher temperatures. But what is important is actually it's a combination of both high humidity and temperature that will provide you those warning signs. So once again, if you have a humidity sensor without a temperature sensor, or a temperature sensor without a humidity sensor, you might not be able to pick up these warning signs in its entirety. The other thing is if you have a humidity sensor in one end and then a temperature sensor here, once again, because of those microclimates, you're not really going to be picking up those accurate warning signs. So our suggestion is to have those sensors close together, or at least have those 2 readings in one sensor. The next thing I have added here are wet plants. Now this speaks to dew. It speaks to if you have overhead irrigation. It speaks to if you use misting or fogging and stuff like that. And that's because plants do not like to be wet. Now you might say, well, in the rainforest and the tropics, the plants are wet quite often, but I'm talking more about the commercial crops like lettuce, leafy greens, your tomatoes, your berries. They do not like their plants and their leaves to be wet for an extended period of time. And I'm going to go into detail on why exactly these are warning signs. The last thing I have here are extremes. So when I talk about extremes, I'm talking about, if your plant doesn't like it being too hot, or if it doesn't like it being too cold, or, the light intensity is too much for the plant. All of these extremes are going to cause the plant to get stressed. Now, plants don't necessarily have an immune system the way we think of immunity, like the white blood cells, but they do have a defense system. And if your plants are stressed, this defense system is, weakened. And a lot of pathogens are opportunistic, like botrytis. They like to invade plants that are already weakened or wounded. And the wounding can come from insects, it can come from a myriad of different things, but extremes is really important. The other thing I want to add to this is in my time in science, we did research on trying to come up with a solution for these diseases. And to test the solution, if it worked, we needed to reverse engineer everything that I'm telling you guys here not to do. We did it because we wanted to see if we can get a disease to infect, to make sure that our solution was working. So that could be as simple as putting a plastic bag around the plant, spraying it with water with the disease, the trapped air in there with the water, so the trapped water in there will cause the disease. Or if we're more high tech, we put it into a humidity chamber, crank up the humidity, set it at the ideal temperature, and voila, your disease will happen. So based on these research and understanding the ideals, we can now tell you, let's avoid that.
So now we've come to our case study. Because, you know, all growers know that pest and disease are going to come at some point in their growing operation. And so in this last part of the webinar, we're going to look at the challenges faced by one of our growers, their response, and the outcome that we saw. We also really wanted to share some of the climate data behind it and the numbers as they related to the financial impact. But before we do that, I wanted to provide a little bit of background. This grower in particular is an herb producer based in New Zealand, growing around 20 different types of herbs over an area of 8 acres, or about 3.2 hectares. And their herbs are grown hydroponically and in beds. So just out of interest, does anyone want to take a guess at what type of growing scenario was at the farm? Is this, do you think, one sensor, no sensors, lots of sensors? Go ahead, type it in the chat what you guys think of the amount of sensors that you think this grower had. So we're talking about, do you think one sensor, no sensors, lots of sensors, somewhere in between? Lots of different answers and coming in. So thank you guys for putting those in the chat. But in this instance, this grower had no sensors. They did have automation for irrigation and fertigation, but the climate was actually done manually, meaning all the venting, all the shade cloths and heating, it was all done by hand. So those of you that answered no sensors are correct on this one. Anyway, Dan, why don't you go ahead and walk us through it?
Thanks, Kayla. What we've been talking about today seems to come up in the conversations that we have with the growers that we talk to. And they're either flying blind with no sensors at all, or they have one sensor that services a large area. So this particular grower was struggling with a disease called botrytis. And you may be familiar with this disease because it's very widespread, it's worldwide. In fact, it infects about 500 plus species. So that's a lot of different plants. And it costs the global economy 10 billion a year. So it has a significant impact on our industry. So, and I want to preface this case study by saying that, in a study done by Rabobank, around the 600,000 hectares of greenhouse production out there, about 90% are actually low to medium tech. So this case study speaks to a wide range of growers out there who might have no sensors or one sensor servicing a large area. So let's just talk about the disease itself. As you can see in the image here, those are the basil that he has, those are real photos from the farm, by the way. And what you can see on that brown part, that's the botrytis. So botrytis is a fungus commonly known as gray mold, and it can produce a large amount of spores. And it multiplies very rapidly because of this. And the best practice for this is to keep your greenhouse clean. The sanitization needs to be, slick. But I can tell you from experience that once you have this disease, it's really, really hard to totally eradicate it. And the way botrytis works and the way a lot of pathogens work is they release these propagules or spores. I'm going to use the word spores, okay, because a lot of you are maybe acquainted with spores. And for the lack of a better example, spores are like seeds. Okay, so your seeds need to disperse, they land in the soil, the moisture in the soil causes them to germinate, right? So same with spores, they get dispersed, they fly through the air. It could be mechanical transfer through your tools, it could be through your clothing as you walk by, it could be water splashing. All of these things can spread the spores, they land on your plant and they can sit there for an extended period of time, depending on what pathogen it is. That time can be longer, depending on the environment as well. Some can even overwinter. So you've got like a time bomb, a ticking time bomb on your plant, waiting for that ideal condition for them to germinate. And that germination process requires water. And so this is why I've talked about water and I talked about high humidity, is because for these spores to germinate on your plant, they need that free water and or the high humidity. And the next point is they need it for an extended period of time. So some researchers would say 3 hours, some say 8 to 12 hours. And I think it all depends on the strain perhaps, or it all depends on the conditions that you have. Secondly, it requires an ideal temperature range. So I talked about 55 to 75 Fahrenheit. If you're working in degrees, that's 13 to 23 degrees. That's the ideal range. So if you have these two aligned, your disease is going to multiply really, really fast. Cool. Next page. So let me talk a little bit about the case study. So like I said, this grower is a smaller to medium tech grower, and it was growing basil, and you were having a lot of botrytis issues year on year. And he wasn't able to pinpoint that. And one of it was because he didn't actually have any data to back him up. So we decided to carry out a trial with him, and we installed some sensors, as you can see in this picture. In the green, that's a sensor there. That's only a corner of the greenhouse. There are 3 other sensors, I believe, in that greenhouse. But we wanted to see if we can harness the data to try and be a detective to see if we can pinpoint what the issue was. So we installed these sensors in the autumn to winter period. And the reason we did that was because botrytis was prevalent in that particular season because of the ideal climatic conditions. And so if you guys can see here, you will see that the disease was spotted around this point here. That's the 10th of June. And some of you going, June, hang on a second, isn't that summer? But this is the southern hemisphere, so it's different to a lot of people. But what you can see immediately from the graph on the left is that the humidity was high 2 weeks preceding. Okay, so if you were to zoom out in this graph, you will notice that you don't see this profile anywhere else. So it's a very, very telling sign. But what is really important to note was that what you can see in this circle on the left here was the humidity was high, not just one-off, but it was for an extended period of time. In fact, it was about 3 days. Once again, you can see over here, the humidity was high for 2 days. So no doubt during this period, the dew point was hit, there was surface water, and there was not enough sun perhaps or heat to burn the humidity off. On the right here, in the corresponding time, the temperatures were within those ideal temperature range, that 13 to 23 degrees Celsius or the 55 to 75 Fahrenheit. So these two in combination, and using the data and our understanding of botrytis epidemiology, we were able to say to the grower, look, I think I know what's going on. Now there's a myriad of other things that could go wrong. There's obviously the plants being stressed or wounded, but I think this was enough intelligence for us to go back to the grower and said, look, you need to look after these humidity issues here. All right, so one other thing that I want you to note is that if you look, if you were to look in this period, you'll notice this zigzag up and down, okay? And if you were to look in this period here, you'll also notice this zigzag up and down. And for you who, you guys who are very keen eye, that's the heaters coming on and off at night. But within this period, you'll notice that maybe it happened here and here, but the rest of the time the heater were not on. And that's probably because the set point was not hit during the night. So the temperatures were a lot milder maybe at night, so the heaters did not need to turn on. And that resulted in this really, really high humidity because the heaters were not able to burn those things off. So I think, you know, this was a lesson to the grower, and next time he can avoid all of these different things. And so for you guys, if you're using data, you really need to talk to a pathologist to try to understand it for your specific disease. And using the data, if you don't have the ability to change your climate, I mean, it could be spraying, a timely spray to prevent these things from getting out of control. If you can change your climate, then by all means do something to minimize this impact. So what happened with this grower is he lost 40% of his crop. I wish I had a mic right now, do a mic drop. 40% of his crop was lost. Now, I want you to think about what that would mean to your operation. I'm going to go into the numbers very shortly for this guy's operation. Thankfully, it was only one out of the 3 basil greenhouses that he had. And so that was a smart move on his behalf to diversify his risk. So let's look at the numbers. So like I mentioned, it was only 1 out of the 3 greenhouses. And it was actually 1 out of the 20 greenhouses that he had growing other herbs. So that mint, dill, tarragon, all of these get botrytis as well. But for the purpose of the case study, I want to focus on 1 greenhouse because it's easier to get the numbers. So if you look here, the total greenhouse capacity is 500 kilograms or 1,100 pounds. And in winter and autumn, you know, basil fetches a good price. In fact, basil is very light. So a kilogram of basil is $33 a kilo or $15 a pound. Now, the labor component is $15 an hour, and labor is required to remove the disease, to sanitize, to replant new seedlings. And we estimated that for 5% of loss, that would take 1 hour of labor. The cost for the replacement seedling is $8.33 a tray, and the whole greenhouse can take 30 trays. So let's drill down. So if you can see the revenue loss, if you had a 500 kilogram capacity, and that 500 kilograms, all of that basil will sell because winter, the demand's very high. At 40% loss, that's 6,600. Labor component, if you're assuming that 1 hour for 5% and you've got 40%, effectively times 8, $120. Seedling cost, if you've got 40% loss of the 30 trays at $8.33, that's $100. So total loss, $6,820, $7,000. You might be saying, hey Dan, that's a second-hand car. It's not that expensive. Well, like I mentioned, this was 1 out of 20 greenhouses. And if you multiply this by the volumes that you produce, and I did the maths for a hectare, that would be $179,000. That is a lot of money. If you got 10 hectares, what's that? That's over $1 million. So the cost can really hit hard very quickly if you do not manage your disease. And I think what the point I'm trying to come across here is that if you're a data-driven grower, you can start to make decisions that are proactive and they're educated decisions that if you did not have a sensor, or if you're only using one sensor and not picking up all the hotspots, you can save yourself a lot of headache and a lot of time. And my suggestion is get in touch with a plant pathologist because different diseases are slightly different, and they can help you out, work a plan to mitigate your risk.
So that was one grower's experience, and perhaps some of you here can relate. I mean, when Dan did the math and with the same like proportions wise, yes, it was about 7K for this particular grower. But you know, you do the math for a hectare and you get all the way to $140,000 of potential crop loss. I mean, that is very, very significant. And so unfortunately, a lot of you guys probably have stories of your own. So go ahead and tell us, what pest or disease issues have you wrestled with in the past?
While we're doing that, Paul, I just want to answer one question here. Someone's asked, can we do this for downy mildew and paludism mildew? Their profiles are very similar. Paludism mildew, I know, is slightly higher temperature. You can do some research on that, but yes, you absolutely can do this if you can mitigate those high humidities and ideal temperatures.
And then I do also want to mention, while we're waiting for some final people to come in, there are some of you guys have asked very specific questions. So we can't go through those very specific ones today, but our contact information will be on the last slide. So feel free to email Dan and I with those specific questions if we're not able to answer them in this particular context. But it looks like powdery mildew is definitely the culprit for a lot of you. Next, you know, we're looking at aphids and thrips and botrytis itself. So glad that you guys are on here for those of you that get a lot of botrytis, but any of those diseases are definitely things to watch out for where you need that data for those particular climates.
I just want to speak to that quickly, Kayla. Because it's quite interesting that usually it's a combination of insects and pathogens. Insects carry pathogens on their little feet. Okay, I've done scanning electron microscopy, and on these little insect legs, you'll see all the spores attached. So they transfer spores between plants. The other thing about thrips, for example, aphids, is they pierce the plant, and that creates a wounding. So disease like botrytis, that open wound is saying food. So yes, something important to know.
Unfortunately true. But
cool. So let's talk about the ideal climate monitoring scenario in your greenhouse. So I've got three things here. The first thing is having a wider range of climate readings. Okay, so I already talked to you on the importance of having humidity and temperature together. There are a lot of other readings that you can have, like carbon dioxide, like light readings, and then you've got the derivatives like vapor pressure, you've got absolute humidity, humidity deficit. There's a whole lot of these things that actually, these readings interact with one another. So you have more climate readings, and the important thing is to actually have those sensors near each other, so you can actually start to make some associations or correlations, and you can understand your plant a lot better. And this goes beyond just disease monitoring. Secondly, I have climate data collected across more locations. So this speaks to climate density, data density, okay? And we've talked about those microclimates and how you have pockets of high humidity, so you're not picking up your diseases in certain areas. And I also know that I've spoken to growers where the greenhouse is built on a lean, and so the temperature between one end to the other is maybe even 7 degrees, or is that 44 Fahrenheit, something like that. There's a huge difference in temperature between one end and the other. It could be you've got tree lines. It could be that you have plants at different maturity or different head densities. And so there's a whole lot of different things that create these different microclimates, and having better data density will give you an idea on you know, how to better manage your greenhouse. And lastly is climate readings at various heights. Now, I haven't really seen a lot of literature. Probably haven't seen any literature out there that talks about this whole vertical understanding of your climate. So let me be the first to introduce it, perhaps. You can see on the right here, there's a picture of a tomato, especially for vine plants. You've got your sensors that are generally located in the canopy, but you don't know what's actually happening down at the fruit level. You don't know how much light is getting down to the bottom of the plant. You don't know if you change your head density, how does that affect the humidity lower down? How does that affect the temperature lower down? You have no idea. And so having an idea of what the climate is vertically can actually even help you save on carbon dioxide use if that's what you're using. The other thing is that you can also have sensors above and below your shade screens, and that will give you more information, humidity deficit and stuff like that, which can actually help you time your shade screen closing so you can keep the humidity that you want and let the humidity that you don't want out.
Okay. Now I have an important question for all of you guys to think about. Do you have all of the climate information you need to optimize your yield? Because like we've talked about it, you don't just need a humidity sensor or a temperature sensor or that light sensor, the three most common that we saw earlier. Because growing plants is a very complex business. It's not like you're making a chair or a TV that can happily sit on the shelf until it sells. You're growing something that is alive. It has an expiration date. And there's always so much you need to be aware of throughout the entire growing process, because as we explained before, if you don't have a comprehensive view and you only have one or two sensors, take handheld readings, then you're definitely reactive. And being reactive is bad and it's exhausting because you always feel like you're putting out fires. There's always a new problem, and it's hard to think about the big picture when you're waist deep in the problem of the day. Specifically, in one of our customer interviews that I wanted to share, they said that they wanted to be more proactive, and they specifically used that word so they could use less spray or know the best time possible of when to spray. Because yes, there are always going to be fires to put out, but imagine if you could have the right information, do less manual data gathering, and being proactive. Doesn't that sound like a much better situation? I genuinely think so. And the question is, would you like help with all of this? Because like we talked about in the beginning, this is the current status for most of you. And fortunately, we have been in the industry for over 20 years and have heard these things over and over and over again, which is why we did develop a product to solve them. So Folium is a sensor that delivers a richer picture of your growing environment. And the beauty of it is that it's wireless. It has 6 sensors in one single unit and provides you with the data density that will ensure that you don't suffer through what our case study customer did. And I actually have one of them here right now with me on my desk. It helps you identify microclimates by displaying the information visually through heat maps or graphically so you can look at multiple readings at once. And it also has an app for easier remote access with alerts and notifications. Then we wanted to make it really, really easy to install. So all you have to do is turn it on, connect it to your account, and just go ahead and hang it up. It really is that easy. And lastly, I wanted to show it's just powered by 2C batteries right there. And so they'll last you about a year. And then if you want to shift the sensor somewhere else in the greenhouse, then you can easily do that as well. Sorry, I'm going to put that down. One of the really cool things that I like about Folium is that it can, obviously reveal your microclimates. And so here on the screen is a view of relative humidity, showing the variation in relative humidity across that greenhouse. This variance could have a significant impact. I mean, we're going from 49 in one corner to 57% in another, and it could significantly impact your crop quality and production output, because plants do need that whole climate to be optimized. And if something like single point, if humidity is out of whack, then you will definitely see production outputs from that. Then the other thing is that Folium will display, another sensor is CO2 readings. And so CO2 dosing is a significant cost. So understanding the optimal time to dose, especially as it relates to temperature and light levels, because all of them, you need to have enough light and the plant activated for the day and a certain temperature to have it uptake the CO2, as well as making sure you have an even distribution throughout the space, are all key in understanding and providing this optimal growing environment without wasting an unnecessary amount of CO2 and ultimately money, because it's so expensive. Then Dan referenced it before, but Folium can also show you a vertical view. So crops like tomatoes or cucumbers do have varying microclimates throughout the canopy, and understanding where those are can help you manage the crop better. So as you can see, as a whole, Folium can help you leverage a richer climate data to make better growing decisions by showing you what is actually going on in your environment at a very granular level. And I'm excited. We do have a special offer for you guys attending today. If you want to be proactive about your growing environment and free up your time for those big picture things, we're offering a Folium starter pack plus 4 fantastic bonuses. And so this starter pack includes the 4 units with 6 units apiece. So it's like you're purchasing 24 individual sensors, 1-year subscription, a gateway, which connects, the Folium sensors, push the data packets to the gateway, which is connected to Wi-Fi to send it up to the cloud, a power supply, as well as a startup guide and installation video. And I do also want to note that this there is free shipping worldwide with this offer that you see here. Then I'm very excited. Bonus number 1 is an interview with plant pathologist Dr. Nicole Goche. This interview was really insightful. I really enjoyed doing it. And as someone who doesn't know the ins and outs of plant disease like you do, Dan, and as I'm sure many growers here, I definitely learned a lot. She did talk a lot about a lot of different types of disease, but also explained that botrytis is everywhere. Like Dan said earlier, it's an opportunistic pathogen, which means it's just sitting there waiting for the plant to be stressed, a leaf or stem to die in order to infect the plant. It's already there in your space. And as we know, it's really hard to get rid of without incurring significant crop loss. Then we also discussed ways of breaking the cycle and what can be done with the processes and data in order to prevent and mitigate the risk of many plant diseases. And so there's lots of invaluable insights, and I was so excited to include this as a bonus. Then bonus number 2 is 2 private concierge calls with our Folium field team, because it's great to have data. It's really, really cool. But one of the biggest challenges that our customers experience is, what the heck do you do with it? So these 2 calls will help you guys with that. The first call will be to assess the initial 3 months of your data and to work with you to devise a plan for going forward. And then the second call happens 3 months after that, and reevaluates the plan once you've executed it. And then we'll help you analyze the new data and make adjustments to help you and your team improve even further. These 2 30-minute concierge calls are your key to identifying those microclimates so you can take the actions that you need to optimize your crop management decisions and ultimately increase your bottom line. Then bonus number 3 is a 5-day mini course teaching those practical steps to improve your climate and make the best crop management decisions possible. So in the CMO course, we're going to cover some challenges in CO2 injection and management, temperature inconsistencies, light and differences between PAR and RAD, because both are included in the sensor, and different challenges in humidity and what to do about it. Then lastly is is a 23-page climate guide to CEA and greenhouse growing. This comprehensive guide does discuss all aspects of the controlled environmental agriculture, how different types of light affect CEA crops, the impacts of microclimate, and current solutions available to mitigate some of these climate conditions. It is complete with references to published studies so you can explore deeper if you would like, and comments from our Director of Crop Science and Agronomy. And so this guide is an invaluable resource for all of our growers. So in total, that's $400 worth of bonuses. And then add back in the starter pack for that, and you get over $5,600 worth of sensors, software, and bonuses for only $5,207. So this offer is exclusively for those of you attending on the webinar today. You won't find it advertised on our website or anywhere else, which is why you haven't seen it anywhere before till now. So if you like the idea of having a better view of your climate, follow the link that we're getting ready to post in the chat, or type that address in your browser, webinar.autogrow.com/order, to grab your folium starter pack and all of these bonuses. And then for those of you that will be watching the replay, you're also still in luck. You can take advantage of the offer. Go ahead, click the link in the chat, or type that address in your browser. It's webinar.autogrow.com/order. So while we've been doing all of this lovely presenting, our team in the background has been gathering your great questions. And so we do have some. We wanted to take a second after all that information to answer a lot of your questions. So Dan, do you have one to start us off with?
Sure, I'll answer the first one from Matthias. It says, do you have an example showing how much crop yield improvement a grower could achieve by deploying your system? And if yes, what crop and what type of system and the approximate cost to deploy? So we are working with growers. Folium is, this folium sensor network is a very new product for us. But we're working with various growers doing trials so that we can understand this. And it all depends on your setup. Depends how tech you already are with your growing. There are a lot of readings in there, so it will help you. But the key here is using the data to make decisions. So it's all on the growers to make these decisions to improve your crop yield. The data will inform you, and the data together with knowledge and information will help you make these more educated decisions. The next thing here is what is the range?
Okay, I wanted to answer Luke's question, Dan. He asked, would the microclimates be more pronounced in a larger vertical farming space? And how would you manage he said thermoclines from forming in your facility? So because you, in a indoor space, absolutely, the bigger the space, the more, if you have vertical racking, things like that, is definitely going to have those variations in a microclimate. HVAC is fantastic, but there's those little corners that don't just quite get circulated around. Then in the greenhouse scenario, well, and that's especially the case if you have that vertical racking, that will make it more difficult for air to move around, and you're most definitely going to have those microclimates vertically. Then if we're looking at a greenhouse space, what was really cool or really interesting is, we specifically reference things like tomatoes or cucumbers, or if you hydroponically grow hops, which I think is the coolest thing on the planet. Yes, you're going to experience microclimates in a large vertical space, things like that. But the other thing to consider is that even if you're growing, usually Dutch style, but let's say a large vertical, like very high greenhouse, one of the things that we experienced where I used to work is that, understanding the temperature differential above a shade screen and below the shade screen. Because if you live in a particularly cold place where, in the middle of winter, you pull that shade screen at night, you're gonna have that air between the peak and the shade screen to be far colder than what's in that space below. And so in the morning, when you wanna get every bit of light in the winter that you possibly can, you can't just pull open those shade screens, because then you're going to dump all that cold air on top and you're going to burn the crops. And so just adequately understanding that temperature differential below and above that shade screen is definitely something where, even if you aren't growing a vertical crop, understanding microclimates vertically is really, really key.
Thanks, Kayla. And the next question from Erica says, thanks and good point. We do grow vertically and currently have one folium above, but not have a sensor midway or towards the bottom. Yeah, that is a really, really interesting thing. And, Erica, if you do discover the different microclimates vertically and you're happy to chat with us, we're very happy to have a chat with you and what you've found. One thing I want to mention is that, folium is in development, and we're always increasing different things for the sensors, for the platform, and so forth. So if you'd like to be part of the journey that we're going through, we're really happy to chat with you send me an email or Kayla an email. We would love to chat to see what would you like to see as part of the sensor, or what have you found? Please do get in touch with us. The next question is, what's the range distance of the folium sensors to the receiver box? Very good question, Talbot. So we've done some extensive testing with this. We've done outdoor testing on a beach, actually, because you can get the, the length. And we got around 500 to 700 meters between one sensor to the gateway. Now, we've tested also inside a tomato greenhouse. It's probably the hardest to get range because your foliage is very thick. We've tested it above, and that was about 150 meters. But that was the length that we could test. I mean, we didn't go any further because we couldn't go any further. But I do want to make mention that actually folium is a sensor network. So if a folium is powered, it acts as an extender. So it will take your signal from one folium and pass it on. And as long as it's powered, it will pass those signals on. So your range can effectively be extended limitless. We haven't tested to see how far we can go, but we can really extend the range using that capability. The next question from Patrick is the use of folium limited to the greenhouse glasshouse operations, and can it be applied to covered tunnel operation? Yeah, good question. We've been using the term greenhouse, Kayla, very loosely, but and we've missed out a whole group of growers here that are growing in tunnels. Absolutely, yes. We should probably have said covered crops, but they can be used in fact, the case study we did, they had greenhouses, and the case study was done in greenhouses, but we actually also had sensors in the tunnel houses that they had. The next question, can a basil crop have a different microclimate above the canopy and below the canopy? Well, it all depends on how high you grow your basil. In some countries, you would grow it on the ground, and they'll grow up to 1 meter high. If that's the case, yes. Is it that important? I don't think so. I think if you have something in the middle of the crop, that's good enough. I mean, the size of the folium is about that high, and so that's usually the height of a basil plant.
So I do want to answer the question, can data be imported into a database? So we do have a variety of different ways you can view your data. Graphically with multiple readings on one graph, with a heat map, in a table, and you can export that data to a CSV file. But one of the really cool things, and I'm sure you guys saw it on Horta Daily this week, is we just recently released our API. And so what that means is that, yes, you can import your data into another database using our API. And if you want to go look at that API, you can go to labs.autogrow.com, which is where you can look for that API specifically for folium, as well as all of our other products are built with that open one-way API. So thanks for the question.
Cool. Next question from Matt says, should carbon dioxide sensors be placed at different heights, since carbon dioxide is slightly heavier than air and has the tendency to sink? I do also know that if you open up the vents, you lose your carbon dioxide, so they do drift upwards. I think for this particular question, it would be interesting if you do have a vertical profile of these climates to do that kind of study. You would have to talk to a more specialized person about this particular question. But I would say yes, but you'd have to do your research on that, and definitely having that vertical profile will help you and enable you to do those kind of make those decisions.
So just to quickly review, today, if you purchase, you will get the Folium Starter Pack, plus bonus number 1, which is that interview with plant pathologist, Dr. Nicole Goche, 2 30-minute concierge calls with the Folium field team, the 5-day mini course we talked about, as well as the climate guide to CEA and greenhouse growing. So again, this offer is only available on this webinar, and it will expire when in the replay does on Monday, August 31st at 9 p.m. Eastern time. So follow the link posted in the chat and type that address in your browser, webinar.autogrow.com/order, to grab that now. I do want to say we wanted to go ahead and start wrapping things up given the time, but know that if we didn't answer your question, Dan and I are going to stay after we wrap up in a second to answer any lingering questions that you guys want answered. So if you'd like to stay on, go ahead. We will be here for you guys.
Cool, thanks. We're going to wrap up. I just want to answer one more question if I can, Kayla. It's a question from Terry, and he's asking, can we hang these sensors in a particular room and then a few months after you have the data, make the necessary adjustments, you move the sensors to another room? Absolutely. So the beautiful thing about this Folium sensor network is it's wireless, it's small, you can move it around, and I think that versatility is, gives it its edge. And yes, you can plug and walk away. So it's that simple. Okay, so to wrap up today, we talked about the common growing scenarios and the limitations for spotting disease. We talked about some of the main warning signs for fungal disease based on the understanding of how the disease itself works. And then I walked you through a case study that we did with one of our growers. And in that case study, we used one of the Folium sensor networks that Kayla then introduced to you. So like we've promised, we're going to drop in the case study, a PDF form of the case study in the chat below. Yep, and so that's everything that we have for today.
So guys, thank you so much for being here with Dan and I. We hope that we've provided some valuable insights in the climate conditions that do cause fungal disease and the serious impact that it can have on your grower's pocket and the bottom line. With this info, you should be clear on where you can go from here and what measures you need to put in place. Of course, we would absolutely love to help you move forward and to give you the benefit of our expertise, but regardless, this was a ton of fun, guys. We've enjoyed your company and appreciate you spending the time with us. If you need to contact us, then please get in touch using the details on the screen. Like I said, the webinar is officially over, but for those of you that would like to stay, we will be answering some more of the questions that were posted in the Q&A box. So there are still some good ones. But for those of you that do need to head out, thank you for joining us and have a great rest of the day.
Thank you, guys. And goodbye. So let's go back to some of the questions, Kayla. So which growers, let's answer Dr. Greenhouse. Which growers is it important for, and would you use it to measure VPD? I think it's important for every grower. Plants need a certain climate to grow more efficiently in, and there's a certain climate that you want to avoid. So the disease don't attack your plant. So it goes across every grower. I mean, we're currently working with tomato growers, we're working with berry growers, we're working with leafy green growers. We're working across a wide range of growers. And so I think it's important for everybody. Now, the thing is, would you use it to measure VPD? Very good point. And so, like I mentioned, Folium is something that we're continuing to develop. So VPD is one of the things that growers have said, yes, please, VPD. So we will be looking into that. In fact, we're already looking into a leaf sensor. We can't promise that we'll have the leaf sensor, but this is where we really appreciate you guys to give us your feedback. Send me an email, the email's on there, or Kayla an email, and would love to get in touch with you and just find out from you what are the measurements that you really want. And we can look at putting that into the Folium in a further stage.
So I would like to answer one question, asking if our system can be connected to a CO2 tank and distribute whenever the levels drop down. So Folium is a sensor network. It gives you notifications in those specific microclimates because you have data, you have more sensors at scale at a reasonable price. Now, if you're looking for more of that CO2 automation and control, we do offer other things like that. Look at our multigram or our IntelliClimate, would both be able to do that. But this folium is really, really key, because what it does is it tells you how that distribution is across the entire space, things like that. Then I also wanted to, before I hand it back to you, Dan, there was also a question about calibration. And so the really cool thing, because it's wireless, right? All you have to do is hold the button down on the bottom. So this is our power button. And so what you would do is hold this down for 20 seconds, or I apologize, take it outside to get ambient CO2, hold the button down for 20 seconds, that's going to recalibrate things. And so that'll make sure that your CO2 specifically is in check and that you're good to go. It really is that easy. We wanted a consumer grade install at a commercial grade scale. And so all of the sensors are in here are definitely research grade, commercial grade, and definitely good to go, but it is easy to set up. Back to you, Dan.
Cool. Next question. Can I integrate folium with the current multi-grow system? The answer is not yet. But one thing that we do have is we have an API that we just made press release about recently. An API allows you to pull the data out of folium so that you can use it. And if you have a development team, you can add it to your other sensors or your management system. So yes, it is versatile in that sense that you can pull the data out.
There's a really, really good question here that I'd like to touch on. And Dan, if you have any other input, I'd be more than happy to jump in. Is would it be more effective to have individual sensor modules based on a crop than a consolidated device like folium? Now, something like that is really, really interesting, and that's why we talked a lot about how the different sensor types all relate into the collective optimal and growing environment, and so that's why all of the sensor units all are in one space, or all in one unit, because what you need is you need to be able to identify all of those different factors in your microclimates for optimal plant growth across the board. Because normally, like you said, you only have maybe one temperature sensor here or there, or you have one or two comprehensive sensors, maybe in the entire environment. But like if you've ever seen, waves of growth or things like that, that's microclimates. Other things like in looking at individual sensors is that it just doesn't give a comprehensive view, because then you have to pick and choose. And so by having all of the sensors is in one unit is able to let you have that comprehensive view to know exactly what's going on. And we could provide, and I'm sure Dan's got countless number of examples. One of my favorites, because we did dose CO2, is that CO2 is only uptaken by a plant at certain temperature ranges and certain light levels. So the example that I like to use is that, if you dose CO2 in the morning, right as the sun comes up, you need to know that you have the optimal light levels, so the plant has jump started its growth for the day in transpiration and photosynthesis in order to be able to adequately uptake that CO2. But by like 10 a.m. when it's getting a little hot in the greenhouse and you have to open up your vents, if you didn't adequately dose CO2 at the time that the light levels and the temperature range was perfect, and you just went ahead and vented, you just vented all that CO2, and that's adding to, the outside world more CO2, as well as just wasting CO2, and that stuff is expensive, and you want to be able to adequately use that. And then I do also want to reiterate that it is, I only have one sensor here, but it is part of a sensor network, and it is that starter pack that we presented to you guys is a pack of 4, so that you guys can start to get that feel of identifying your microclimates and where those are and how we can adjust. That's also why we included the concierge calls, because Dan has done all of our trials. He has extensive greenhouse growing experience and plant pathogen experience, and we want to be able to share that experience, as well as Dr. Thrindu, our agronomist, because like I said before, it's great to have the data, but until you know what to do with it, what good is it? And so that's why we also really included those concierge calls. Anything else you'd like to add for that, Dan?
No, I think you said it well, Kayla. And I think Jonathan's answering the last question. So I think that's all the questions we have for today.
Anybody else? Last minute questions. Speak now, forever hold your peace. And also, as always, like the slide. You know, you can go ahead and email Dan or I. Mine is kayla.waldorf@autogrow.com. Dan's daniel.than@autogrow.com. And for those of you that haven't gone yet, more than welcome. Please go to webinar.autogrow.com/order.
Thank you, everybody.
Looks like there's no other questions. Oh, we've got one from Erica. That falls in your territory, Dan.
Would plant transpiration greatly affect the humidity in the environment? Yes. I mean, so here's the thing: is if your plants are at different stages, life stages, you know, some crops are a lot more mature than others. Yes, it will. It will affect your humidity, especially in that little microclimate. It might not affect the humidity drastically in your huge greenhouse, but definitely in that little microclimate, and especially if your crops are grown very closely to one another, that density. If that density is high, yes, it will be a huge problem. I hope that answers your question, Erica.
And then we got one more, Dan.
Same as the previous, will folium work with Autogrow? Not at this stage. But like I said, we always appreciate feedback, and come talk to us. And if the demand's high enough, we will look at something like that. Will 2 foliums be sufficient for a 30-foot by, hey, Kayla, can you convert that into meters?
Oh my goodness. Hold on, let me pull
Sorry,
up
I'm using meters here. Let me just quickly do
so roughly divide by 3. So what, 10 meters by 4 meters by 3 and a little bit more meters?
That's almost like a shipping container. Yeah, I think it would be sufficient depending what you're growing and how many crops you're growing in there, and what you're trying to achieve. Yes, I think it would be enough. Thank you, Tony. Appreciate that. Thank you, Pankaj, as well.
Awesome. Anybody else got any questions?
I think we're good.
All right, we'll call it. Thank you guys so much for being with us here today. Like I said, have any further questions later today or in the next couple days, feel free to reach out to us. Even if we can't answer it, we'll get you to the right person. But with that, thank you for joining us. Have a fantastic day, guys.
Thanks, guys. See you later.